So chapter 3, we looked at state space modeling. Today we look at converting transfer function to state space. What is the function in MATLAB for this?
TF number 2 SF.
TF2 SF, right? Okay. So we'll take an example. Let's look at this. It's very straightforward, especially the one with numerator and the constant in the numerator. We have C of S over R of S is equal to S cube plus 9 S squared 26S. Okay. So how do we convert this transfer function into a state space model? What is the order of the system? So here, when I write this, you have to understand here, C of S is what? C of S is the response or output. Okay. Transfer function is the ratio of output to input. R of S is the input. The order of the system here is, you have to understand, it's very simple. Order of system is equal to order of degree of polynomial in the denominator.
What does that say? Right by the CS before the CS.
Here, so degree of polynomial in the denominator. What is the degree of polynomial in the denominator? 3. So it's a third order system. Okay. Now, step 1. Find order of system, which is equal to 3. Therefore, number of state variables is equal to what? Number of state variables is always equal to order of the system. There is a rule of thumb here. So here it is 3 state variables. Okay. So the first step, what you do is you cross multiply. First step is you identify this, and then second step you cross multiply. Step 3, step 2. Cross multiply. It will be what? C of S into S cube plus 9 and you take inverse Laplace transform. What is the inverse Laplace transform of left hand side? So inverse Laplace inverse of this is we have this cube C of S plus 9S square C of S plus 26S C of S plus 24 C of S is equal to 24 R. You need to take the Laplace of Laplace inverse. Okay. What you're going to end up doing here is C triple dot triple prime T plus 9 plus 26 24 R. So what you've done is you've converted a polynomial in S. Okay. So this is the Laplace equivalent. This is the differential equation. So step 3. Assign system variables to state variables. So you have how many system variables, state variables are going to be there? Z1 is equal to C of t. Z2 is C dot of t. And Z3 is C. Accordingly, what you're going to get is Z1 dot is equal to Z2. Z2 dot is Z3. Z3 dot is C triple dot, which is equal to minus 24 C1 minus 26 Z2 minus 9 Z3 plus 24 R. Okay. So you have your three equations here, state equations. Right? These are state equations. And what is the output equation? What is the output here? Output? You don't know the output? What is the output? No clue?
It's CS.
So what is the equivalent of that?
24.
Huh?
Or 24 hours over.
CT.
You cannot, right. C of t. You cannot equate, don't do that mistake, okay? Don't equate this like that. Never. In any this thing, just don't equate that. That is not the right way of doing math. Okay? So C output is C of t, right? What is it in terms of?
G1.
Huh?
G1.
Exactly.
G1, G2.
Your y is simply so that is your state equations are, if you write it, you're going to get Z1, Z2, Z3, or if I write it like this, it should be okay with you. It should not be too V dot is equal to zero, 1, 0, 0, 0, 1, minus 24, minus 26, minus 9. Then you have Z plus 0, 0, 1. Y would be equal to 1, 0, 0. So now what you have done is you have just converted the transfer function to state space representation. Now let's look at what would you do if you have a polynomial in the numerator. So in fact, you don't really need to go through this book. If you look at what the pattern is, it's very simple. You have to just look at this. You'll figure out that there are 3 state variables. Okay, there's only you can say this is the output, coefficient of the output, coefficient of the input, and you can simply write that by just looking at it. You don't even have to do this. Okay. 7s. C of s over R of s is equal to 1 divided by Q plus 9 square plus 26 4 into s square plus 7s plus 3. So I can write it as something like this. 1 divided by s cube plus 9s square. So here, what you end up having is the state equations. Looking at this, what you realize is the equations will look something like this. You have Z, it will be exactly the same. A matrix will exactly be the same. The B matrix will now be 0, 0, 1. Actually, there was a mistake there. Did you guys realize that? Hmm? Was there a mistake there?
With which one? Which part?
Tiffany? Did you see it?
Wait, me and
The
first row is 1, 0, 0.
See, writing this, you did not realize any mistake there? Hmm?
Why is that mistake?
Austin?
oh, 24.
Oh.
This is 24. Okay. So what you do is this, now it becomes 1. So the state equations for this becomes 1. And what you do is, you write your output equation here, here. So that's what changes here. If you see the numerator here, that is 24 because the numerator was 24. Okay. Here the numerator is 1, so this will be the state equation. Your output equation C of T here B. You have output equation will look something like this. S square into 1 square into Z1 of S plus 7S into Z1 of S plus 2. When you take an inverse Laplace transform, you're going to get C of t is equal to Z1 double dot of t plus 7 Z1 dot of t and what you're going to notice here is this is Z3 of t. This is 7 Z2 of t plus 2 Z1. Okay. So your output equation will look something like this. 7 If you look again here, there's a pattern. So compare what was the transfer function here. The transfer function was C of S divided by R of S is equal to 24 divided by S cube plus 9 squared plus 26s plus 24. Okay. And here the transfer function is this. C of S over R of S is equal to S cube plus 7S plus 2 divided by cube plus 9 squared. There is a very simple pattern. It's a third order polynomial, 3 state variables. You see 3 state variables, this is 3 by 1. I want everyone to realize that this Z is 3 by 1. Z1, Z2, Z3. Okay? This is again 3 by 1. Z1 dot, Z2 dot, Z3 dot. Okay? Everybody is okay with that? Okay. So Z1 dot is what? Z2. So you get it here. You get that 1 here. Z2 dot is Z3. You get your 1 here. And Z3 dot is the polynomial. Okay. So if you look at the polynomial, it is 9. Of course, this is 9 into Z3, right? So this is Z1. Sorry, this is Z1 minus 24. This is Z2 minus 26. This is Z2. And whatever is here will go as in. If it's a constant numerator. You see the pattern? Are you able to correlate?
What did you say about the numerator? You say it's the same numerator?
If it's a constant numerator, it will just end up here.
So, since this is a
So that is, the numerator there is a polynomial. Everybody follows this?
I don't understand what you're saying about the numerator.
Numerator will end up here. See, numerator is what? This is, see, if you have missed class, it will be difficult. Because you have to understand this format. Everybody understands this format. Huh? State space model. This is Z is equal to AZ plus BU. is R of S. B is the matrix associated with the input. If you cross multiply, you'll see that C of S is this Z3 double dot or C triple dot is associated with this input. Okay, so that's the reason this 24 ends up here. All right. If you're doing this, everything is pretty same. All you need to look at is, you look at this, you just have to split it like this into two, into the product. Your state matrix, this is the state matrix, right, or the state equations. The state equations will be exactly the same as this, except the numerator here is what? What is the numerator here?
S4 and S7.
Right, but this, for the state equations, the numerator is 1. You see this?
Oh.
So this 1 will end up here. Your output equation will vary. Output equation will be the numerator.
Wait, but the oh, you said the numerator is 1, not the denominator. Okay, yeah.
The output equation here, what is the output equation here? Simply 1. Okay. Here the output equation is the numerator, reverse of the numerator. You see the reverse of the numerator?
Like
271. Huh?
Like 272.
271. So it is S square 2 coefficients. Have to look at the coefficient. 271. It is always reverse. Even in this case, it is reverse. If you see here, it is 24, 26, 9. 24, 26, 9. Okay? So this is how you convert state space to transfer function. And you can do the other way as well. So if you look at this, how do you convert this to transfer function? If you are given that state space, can you convert it to transfer function? Looking at it?
Yeah.
How did you get that 24?
Hmm?
How did you get that 24?
Look back in your notes.
The 24 was by the RT.
So the numerator is always the output?
Let's go
Hmm?
to
And then
The numerator is always the output?
The numerator is
So
not
it's
always
all-
the output. Numerator is what? The coefficient of numerator is the coefficient of the input, not the output.
Dr. Sunday, over there in the left, you didn't have the 24. Is that separate from this up here?
No, this 24.
No, I think he's saying in the matrix you don't have the 24 where the 1 is.
That's what the coefficient of the coefficient of input is the numerator.
So so that is separate from this. This matrix is not the same as this matrix.
This is a different problem.
Right. That was his question.
What do you end up here? If you cross multiply, you end up like this. C triple dot. I did that. I just did that. C double dot T.
How about that?
Equal to 24 f of p, right? Or r of p.
That's just
The coefficient. This coefficient has to go somewhere, right?
The 24.
That's where it comes from.
Okay.
So if you, when you move everything on the left, right hand side, this is what? This thing, everything has moved on the right hand side. So the 24 remains somewhere.
So what I'm asking is the y equation. Let's call it output equation.
Right. The y equation here is,
So when you get 1, 0, 0, that's because you already used the 24. You already know
Yes.
the 1.
right.
And then this one, you only use the 1. So now you're going to the other 1.
So this is how you do it. I can give you the breakup as to why this is the case, but I think it's not required. If you just keep a track of what is the pattern, what is the This thing. It will
Okay.
be- Yeah. Okay.
So, like, the second degree, I mean, 9x squared plus 26x plus 24 goes like at the bottom. What about that coefficient of the x cube?
That's what happens there. This thing
Right.
is equal to everything goes on the other side.
Oh, okay, that's
So
the.
this is what? This Z3 dot. Z3 dot is what? What is Z3 dot?
Let's keep, well, C triple dot.
C triple dot. So C triple dot is equal to all of this. That's what is happening.
You said you put all
C triple dot. If you extract C triple dot, what are you going to get?
That's the equation.
Huh? What are you going to get, Micah? C triple dot equal to.
if you move everything to the side.
Yeah, that's what you're seeing here. If you move, whatever you have moved on the right hand side is what this is.
And then, okay.
Whatever you have moved on the right hand side, you see 24, minus 24, you see minus 26, you see minus 9, and you see 24. That's what it is.
So the top two rows will always be the same. The top two rows will always be
Will
the same.
will almost always be the same. Because that's how you do it. Right? You'll say Z1 equal to Z1 dot equal to Z2. So that's what by default that's what you can change. You can get creative about how you assign these state variables. But more often than not, that is how it will be. Okay? Alright, we'll quickly take a look at is Dr. Khan going to be here? I don't want you to. No.
It's not that we have this, like, online class.
Huh?
It's like online class that we have to be there.
Okay, then.
Yeah, it's nice to meet you. So,
Huh?
it's nice to meet you.
Yeah, but you just have something to do that.
Hmm?
I know.
You just have something to do that.
Yeah, I was telling them that starts in 2 minutes.
So you guys need to do nodal analysis. You'll have to take it up some other time.
Can we do it Wednesday?
Hmm?
Can we do it Wednesday?
But you have to submit your homeworks today. If you're not done it, that's fine. Just give me
If
whatever.
you didn't know the 20 is so fast.
That's fine.
Okay. So do you still want the book thing?
Yeah, you still want
You can give the book if you have done it. That will be better.
Or can we just give the sheets?
Yeah, I need to
It's up to you. If you want to give the book, you can give the book. If you want to give the sheet, I would prefer book. But if you want, if you no, that's
I told you I
that's a little too much. See?
Well, you told me that I couldn't do, but I told you want to hold on here.
Staple it.
Yeah, I think.
Raju, we have to be more professional than this. You can't look at this. Use, what is this? What did you do here? You have to be more professional than this. You cannot do this. Is not acceptable.
You got my time? something here. It's slightly out of order. So like this is my first page where I'm telling the assignment. Then I'll go to 8, 9, then there's 18, and then there's 3. You see, then 27, 30, 32, and then 54. So the one that but I still want to figure out who it is, you know.
Oh,
Whose pencil is this?
Tiffany's.
Dr. Sunday, when are you going to be in your office today?
I'll be in my office most of the day. I have something at, I think, 2 o'clock. We have a satellite design lab, but otherwise I'll be in my office.
okay, alright. See you later.
Alright.